Okay, welcome back to another video. Today we're going to continue looking at problems that involve the inverse trig functions. If you've not watched the first video, I know the first video is about an hour long, but if you don't watch the first video and you just jump into this one, it's not going to make any sense. Okay, this one is just like a continuation, and the problems we're going to do today are much more difficult than the problems from the first video and that first assignment I posted. So do not just jump into this one again, you'll just be confused and it won't really make near as much sense. Okay, so today we're going to look at problems where instead of giving us number values, they're going to give us algebraic expressions. And so what I mean by that is so let's take a look at this problem. If they ask me to find the cosine of the tangent inverse of x, well, what do I got to do with that? Okay, now just going back to the last thing we left off with, we know that the inverse trig functions, when I apply an inverse trig function to something, it gives me out an angle. Okay, and if they give me a numerical value here, if this said the square root of 3 or 1 or something, I would decide, okay, is it a unit circle value? Now, if this was tangent inverse of 1, tangent inverse of 1 is pi over 4, and then I would find the cosine of pi over 4. And so that's what we did in the last video. If they gave me something here that was like 3/4 or something like that, well, that's not a unit circle value that we have memorized, but it is something I could just simply draw a triangle for. But again, in the last video, in the last assignment I gave you, whatever was sitting here was always some number. Maybe it was from the unit circle, maybe it was some other number that you just had to use a triangle for. But this time on the problems I'm giving you today, we're kind of taking it to the next level, and they're just giving me an algebraic expression there instead of just straight numbers. However, this problem really isn't too bad. It's the same idea as the ones in the previous video where we just end up drawing a triangle anyways. So I'm going to draw a right triangle. Now remember, when I'm taking tangent inverse or sine inverse, cosine inverse, whatever, when I'm doing an inverse trig function, the inverse trig function represents the angle at which this thing, whatever that expression, occurs at. Okay, so you can call your angle whatever you want. Typically the first angle I choose is I'll just call it theta. Now somewhere in my picture, one of the acute angles, I'll call that angle theta. I'll either put it here or I'll put it here. I'll just put it here for consistency. So there's my angle theta. So I know that this right here represents theta. And then I'll think, okay, tangent matches up the opposite over the adjacent. So if tangent inverse of x is equal to some angle called theta, then that means that tangent of theta equals the opposite over the adjacent. Well, all they have sitting here is an x, but guess what? X is the same thing as x over 1. And so that means my opposite side is x and my adjacent side is 1. So I can label my triangle as x over 1. So they gave me an algebraic expression. They didn't just give me some number here. But I can do the same thing we did in the last video, which is just draw a triangle still. So the tangent of theta is the opposite over the adjacent. Another way to say that is the inverse tangent of opposite over adjacent is theta. And so if I want the missing side here, well, how do you find the missing side in the right triangle? You use the Pythagorean theorem. So I know that 1 squared plus x squared equals c squared. Just call the hypotenuse c for now. And 1 squared is 1, so I get 1 plus x squared equals c squared. I'll take the square root on both sides. You cannot simplify the square root of 1 plus x squared, so it's just the square root of 1 plus x squared. The square root of c squared, well, normally it would be the absolute value of c, but since c represents this length, c can't be negative, so I don't need the absolute value bars. So in other words, the hypotenuse there is just the square root of 1 plus x squared. So the square root of 1 plus x squared. Again, this is just kind of scratch work off to the side. So coming back to this, I want to say, what does this expression equal? Well, this expression is equal to the cosine of, well, what do we say tangent inverse represented? Tangent inverse represents the angle where the opposite over adjacent is x over 1. That angle we labeled as theta, so this is really just cosine of theta. And what's cosine of theta? Well, we have the triangle for that. Cosine of theta is the adjacent over the hypotenuse. So it's just 1 over the square root of 1 plus x squared, and that's it. That's the answer. So don't overthink these. It's not like, oh my gosh, how do I do this? Like they suddenly threw some variables here instead of just straight numbers. Well, it's the same sort of idea. We still just go back and we say what we know about right triangles, and we just label the sides now with the variable expressions they gave us. So it really shouldn't be too bad or too different. If you've already watched the first video, it's really not much of a leap from there. Okay, so let's look at another one. So what if I wanted this? What if I wanted the sine of arc cosine of x? Remember, again, from the last video, when they write arc, that's the same thing. They could have written cosine inverse of x. They mean the same thing. Saying it's arc cosine or inverse cosine, those are synonymous with each other. And so, like I've explained, some books use one or the other. Some books use both. In AP Calculus, they expect that you know both, although the AP Calculus book strictly uses arc cosine for the most part, arc, instead of the inverse trig function. Okay, so anyhow, I want to find this. Same thing as before. And so what I want to do is I want to draw a triangle just like last time, because again, right here, they didn't give me a number, so it's not like I can decide whether it's on the unit circle or decide should I draw a triangle. If it's just a variable expression, automatically I know, you know what, I should just draw a triangle. Draw a right triangle. And, well, what I need is I need to decide, well, arc cosine or inverse cosine represents some angle where the adjacent over the hypotenuse is x. So again, call that angle something. I probably don't want to call it x because I'm already using x for the variable here. So just call it something else. So like I said, most of the time I just call it theta. And remember, x is the same thing as x over 1. And so again, if we think about what cosine is the ratio of, cosine is the ratio of the adjacent side over the hypotenuse. So the adjacent side would be labeled as x, the hypotenuse would be 1. And so if I want to complete that right triangle, if I want to write the missing side length, again, just use Pythagorean theorem. So I know that x squared plus b squared equals 1 squared, right? This squared plus this squared equals this squared. So x squared plus b squared equals 1, because 1 squared is just 1. And I'm trying to solve for the missing side that I'm just calling b for now. So I'm going to subtract x squared to the other side. If I subtract x squared to the other side, I get b squared equals 1 minus x squared. And then now what do? I take the square root on both sides. So I take the square root here and I take the square root here. The square root of b squared is just b because, again, b can't be negative. On the other side, the square root of 1 minus x squared doesn't simplify. It's just the square root of 1 minus x squared. So that means this side length right here is the square root of 1 minus x squared. So we've drawn the triangle. We labeled it according to adjacent over hypotenuse here, adjacent over hypotenuse. We use a Pythagorean theorem to find the missing side length. So what I'm really asking in this problem is, well, what's the sine of this expression? But this expression, an inverse trig function, represents an angle. Well, we called that angle theta, so what they're really asking me is, well, what's the sine of theta? And I can figure out what the sine of theta is by simply looking at the triangle that we've now drawn. The sine of theta is the opposite over the hypotenuse. So it's the square root of 1 minus x squared over 1, but that's really the square root of 1 minus x squared. And so that's the answer. So early on you'll have some pretty basic problems like this, and all the problems really are still pretty similar. I'm going to give you some harder ones though, because otherwise this is just going to be a lot of repeat over and over and over. So let's look at a more advanced one. So let's say I'm looking at the secant of the inverse sine of, let's do 2 over the square root of x squared plus 4. Okay. So again, I look inside, I'm doing sine inverse. Remember, an inverse trig function again represents some angle. They give me an expression here, it has a variable in it, so this is just some algebraic expression. So I should again just draw a triangle. What does the inverse trig function represent? It represents some angle, and in the case of sine, it's the angle that makes sine equal, the opposite over the hypotenuse. And so again, call that angle something. I'll probably just call it theta. So sine of theta would be the opposite over the hypotenuse. So the opposite side would be 2, and the hypotenuse would be the square root of x squared plus 4. Opposite over hypotenuse, because that's what sine is the ratio of. And just like last time, I'm looking for the missing side length here. So how do you find it? Well, you do Pythagorean theorem. So I know that this squared, I'll just call it a for now, so a squared plus 2 squared is equal to the hypotenuse squared, so the square root of x squared plus 4 squared. So I get a squared plus 4 equals, well, what's going to happen when I square the square root? I just get x squared plus 4. The square root and the square cancel each other out. Now remember, I'm trying to solve for a. So I'll subtract 4 on both sides. A squared equals x squared in that case. And then I'll take the square root on both sides. Square root of a squared is just a, because again, a represents that side length. The square root of x squared, well, I didn't tell you, but in the instructions you have on your assignment, they tell you that x is non-negative. So if x is non-negative, then I don't need absolute value bars on the x either. So a equals x, in other words, this side right here is x. And so what do I want? I want the secant of what this represents. But again, remember, an inverse trig function represents the angle. What do we call the angle? We call the angle theta. So I really just want secant of theta, and we use our triangle to figure that out. Well, secant's the reciprocal of cosine, so instead of adjacent over hypotenuse, it's going to be the hypotenuse over the adjacent. So it's the square root of x squared plus 4 over x. Okay, and that's it. So don't let the fact that they're throwing algebraic expressions in these now throw you off. If you're able to follow the first video and do that and draw triangles and all that, it shouldn't be really that much more difficult. Okay, let's try one more like that. I'm going to do, let's say we have the tangent of the inverse cosine of square root of x squared minus 16 over x. Okay. So once again, I start inside here and I say, okay, well, inverse trig function means this whole expression is just representing some angle. I don't know what that angle is yet. I'll think about what I want to call it. I'll probably just call it theta. And I'll draw a triangle and I'll put theta as one of my acute angles in the triangle. I'll just put it there for consistency again. And what does cosine match up? Cosine matches up the adjacent over the hypotenuse. So this is the adjacent side. So the adjacent side is the square root of x squared minus 16. The hypotenuse must be x. Just like all the other problems so far, I just want to find the missing side, and you find the missing side by doing the Pythagorean theorem. if I find the missing side, it's a squared, so this expression squared plus b squared equals the hypotenuse squared, in this case is x squared. If I square the square root, they cancel each other out. I just get x squared minus 16 plus b squared equals the x squared from the other side. If I were to subtract x squared on both sides, right, they'd make 0 on both sides. So now I get negative 16 plus b squared equals 0. I'll add the 16 to the other side, so b squared equals 16. Take the square root on both sides. B is a side length, so b can't be negative, so b must just be 4. So this side length here is just 4. What are they asking me to do? Well, they're asking me to evaluate this expression or simplify this expression. What does this inside here represent? This represents some angle. We called that angle theta. So they're really asking me simply to find the tangent of theta. And the tangent of theta simply means from theta, what's the opposite over the adjacent? So the answer is just 4 over the square root of x squared minus 16. And then that's it. Don't worry about rationalizing that. It's not really necessary. Okay, so that's the idea. So again, these may look intimidating or difficult at first, but really once you see how they're done, it's really no different than what we've done before. Okay, so let's try another one. Let's do this. Let's say I have cosine of 2 times the inverse cosine of x. So, same thing as before, but they put a number here. They put a 2 here, so okay, we'll deal with that. Ignore the 2 for a second. I mean, it's just 2 times this. And again, what does the inverse trig function represent? That represents some angle. So that's all I'm really worried about right now. Don't worry about the 2 here for a second. Remember this part right here, the cosine inverse of x, that represents some angle again. Probably just call your angle theta. So I'm going to draw my triangle still. Put theta in one of the acute angles. I'll just put it there again. And so remember what cosine represents. Cosine represents the adjacent over the hypotenuse. So x can be written as x over 1. So that means my adjacent side is x, my hypotenuse is 1. And I could use Pythagorean theorem to find the missing side here. So that means that x squared plus b squared equals 1 squared. Right? A squared plus b squared equals the hypotenuse squared. I need b by itself, so I'm going to subtract the x squared to the other side. So I get b squared equals 1 minus x squared. I'll take the square root on both sides. Square root of b squared is b because that represents the side length and b can't be negative. The square root of 1 minus x squared does not simplify, it's the square root of 1 minus x squared. So that means this side length here is the square root of 1 minus x squared. So we have everything we've had from the last couple problems. Make sure we're following this correctly. This is cosine of, well, there's a 2 here, so that 2 is still there. And then what did this part represent? Again, the inverse trig function, that represents the angle. What angle did we call it? We call it theta, so now this is cosine of 2 theta. Right? 2 times the angle, or 2 theta. So now I want the cosine of 2 theta. Oh, that's a double angle. We have double angle formulas. we have a double angle formula for cosine, right? If you go back and you look in your notes, there's actually 3 forms of it. It doesn't really matter which one you use, but remember, one of the double angle formulas is cosine squared theta minus sine squared theta, right? Cosine of 2 theta, the double angle formula for cosine, one of those forms is cosine squared minus sine squared. Now you could use one of the other 2 forms, it doesn't really matter. But the reason why I want to turn this into this is because when my angle is theta, I have the triangle that I can use to figure this out. If I stick with 2 theta, well, I don't have a triangle with an angle called 2 theta, so you can't really stop here, can't really do anything with here. But once I recognize that this is a double angle formula, I'll use one of the double angle formulas for cosine. Doesn't matter which one, just chose one, I chose the first one. So cosine squared theta, well, what's cosine? Cosine is adjacent over hypotenuse, so x over 1 is just x, so it's x squared minus, and then I want sine squared theta, so I want the sine of theta squared, so the sine of theta is the opposite over the hypotenuse, so it's the square root of 1 minus x squared squared. So I have cosine theta squared, and I have sine of theta, and then I'm squaring that. And so what I get is I get x squared minus, now this is going to be some quantity here, so throw it in parentheses so you don't blow a negative. I'm squaring the square root, so I get 1 minus x squared. So I get x squared minus 1 minus negative x squared. So really, I get x squared minus 1 plus x squared. And so that's 2x squared minus 1. So the cosine of 2 theta, or really this expression, is equal to 2x squared minus 1. And then that's it. Stop there. So if they put a number here, 2 or something, then oh, it ends up being a double angle formula. But we still draw the triangle, we still find the missing side length, and so on. Let's try one more, and then we'll call it a video. This next one, as soon as I write it, you'll probably guess what we're going to need to use. Anyhow, let's get to it. Let's say I want to find the sine of 1/2 arc sine of x. So, on the last problem, we had a number sitting here. We had a 2, and it ended up that we had to use the double angle formula. Well, here we have a 1/2. So, probably, if you're watching this, you're like, maybe we'll use the 1/2 angle formula. Well, yeah, exactly. That's what's going to happen. But anyways, we're getting ahead of ourselves. Ignore the 1/2 for a second. We're really just thinking about the arc sine again, or the inverse trig function here. Again, the inverse trig function represents some angle. So I'm going to draw my triangle again. The angle, we call it whatever you want. We've been calling it theta this whole time. Why change? We'll just call it theta. Now remember, x is the same thing as x over 1. So we want the angle, and we called it theta, where the sine is x over 1. In other words, the opposite side is x, the hypotenuse is 1. Right? Because sine is opposite over hypotenuse. And so once again, we'll need to find the missing side length. So once again, we'll use our Pythagorean theorem. So a squared plus x squared equals 1 squared. I need a by itself. I'm trying to find that side length. So I'll subtract x squared from both sides. So a squared equals 1 minus x squared. Take the square root on both sides. Square root of a squared is a. The square root of 1 minus x squared is the square root of 1 minus x squared because it doesn't simplify. So that means this side right here is 1 minus x squared, all inside the square root. And so what we have now, this is now sine. We have the 1/2 here, right? That's 1/2. And what do we call this angle that's represented by the inverse trig function? We called it theta. That's 1/2 of theta. Probably, maybe it would help some of you guys if I wrote it as theta over 2. Right? Whether I write it as half theta or theta over 2, this is now a half angle formula. Okay? So we have the half angle formula in our notes for sine. Now, theta is some acute angle, so theta over 2. If theta is already an acute angle, which means it's between 0 and 90, then theta over 2 is also between 0 and 90. So we're talking about something in the first quadrant. So it's positive square root of, remember this is 1 minus cosine of theta. Whatever this was, this is twice as big, or whatever this angle is, this is half of it, over 2. So this is the square root of 1 minus, well, what's cosine of theta? Cosine of theta is adjacent over hypotenuse, so it's the square root of 1 minus x squared, and then over 2. And that's it. Nothing really to simplify there. I'll just leave it like that. So that's the idea. So some of the problems are pretty straightforward. Sometimes they sneak in a number here, either a 2 or a half, and really just need to go back then and use either the double angle formulas or the half angle formulas. They should be in your notes if you forgot. But anyhow, that's it. I'll post this video. I'll post a corresponding assignment. So be on the lookout for both of those. Thank you for watching.